Welcome to Teams Tuesday, a podcast about mastering the best about what other people have already figured out. Teams Tuesday focuses on insights and lessons that never expire. You will walk away from every episode with actionable insights that help you get better results and be more productive.
This was about as bizarre and easy as it gets.
The client just couldn't make up their mind.
I feel like we had top.
Went from a project of 20 weeks to just 2.
The DevOps was a cultural shift.
This is Teams Tuesday with your host, Peter Ward.
Welcome to Teams Tuesday. It's June the 17th, 2025, and we're rolling through the year quite quickly. I can't believe it's been a month since the last Teams Tuesday. We've got a fantastic guest. Hannah, welcome to Teams Tuesday. How are you?
Hi, Peter. I'm great. How are you?
Not too bad. Now, you're talking about something a bit more interesting, because normally the focus of the podcast is about anything Teams, which is basically how Teams and Copilot is integrated, or Flow, or custom coding, or whatever. So here we talk about quantum computing, and this is a topic that's actually of quite a bit of interest to me and to a lot of people. It's like I wouldn't say it's the new buzzword, but there's definitely a lot more focus on this right now. Like a couple of years ago, like blockchain and Bitcoin was very rock and roll. AI in the last 2-3 years has been very rock and roll. And here we are, quantum computing is very rock and roll. And you're a Microsoft MVP in this as well. So this is quite an interesting like topic in terms of AI and everything. So before we kick into the whole quantum computing stuff, do you just want to give a quick bit of background about yourself?
Yeah, sure. So I'm based in Belgium, in Brussels. I'm Azure architect and currently doing AI because, hey, everyone's doing AI. But my interest lies in quantum computing because I strongly believe that is the future. So my long-term strategy, well, I bet on quantum. And I believe that AI and quantum can perfectly work together. So you can combine AI and quantum. And indeed, like you said, it might sound a little bit like a buzzword, this quantum, right? Especially that quantum physics, it all sounds so scary. Whenever I tell someone that I'm about to talk about quantum on a conference or I have a quantum presentation, they say, "Oh, quantum! Oh, it's a topic from a different universe, right?" And that's something I want to. It's something I want to combat because, well, we can't start deploying, so we can't start using a technology that we are afraid of. So my first mission is to make people less afraid of quantum and help them understand, like, hey, what is it? How can I even start with this quantum technology?
Oh, okay. So so you're based in Brussels and you have a big fan of foreign languages. So how many foreign languages do you learn? How do you know?
Well, so my native tongue is Polish. I speak English, Spanish, French, and I'm learning Flemish. And apparently I can speak Portuguese or Portuñol.
Okay, so you put, I think, everybody on, or myself, Ricky and Omar, to complete shame, actually, on this. Ricky, do you speak any Malayali? Ricky, even though he's American, his heritage is in Kerala, in India, and Omar is from Pakistan. So they speak great English, but I think you're putting the entire crew here to shame, I have to say. Okay, and Dungeons and Dragons, yes, very cool, actually, Dungeons and Dragons and public speaking. In terms of that dragons, are you into all the movies about how to train a dragon and all of this?
No, I haven't watched it. I'm more of a paper and pencil sort of a Dungeons and Dragons fan. My character was called Hanagorn from Aragorn from Lord of the Rings. Do you play Dungeons and Dragons, D&D?
The game, yeah, I do play the video games, yes, on that, yes.
I'm not into the video game, but more of the book, the game master, having a card of your character and doing that all live and having a little video game inside of your own head.
Right. Okay. Quite an imagination here. And also, I understand that you wrote and you sang in a choir for hip hop rapping group. Okay. I didn't realize Belgium had like urban gangster rap, sort of like a subculture.
There's a lot you don't know about Belgium, but it wasn't in Belgium. It was still in Poland. I was 17 back then.
Uh-huh.
And yes, it is quite a story. A group of friends asked me to write a chorus and sing a chorus to the hip hop rapping group. And so I did, and I sang, and then we recorded a music video. And while I was interviewing for Microsoft, they asked me a question like, "Oh, okay, your CV is quite comprehensive. So tell me something that it's not there." And I just stared point blank, and that was the only thing that popped into my head. And I told them about the music video, and then I thought, "Oh God, Hannah, you had an interview with Microsoft, and that's really what popped into your mind." But hey, I got the job. So you might
Very
say
cool.
that thing to it.
I would say
Perhaps they were
respect.
so flabbergasted that they said, okay, we need that girl.
Okay, respect on that. Very cool. Okay, so you're an architect in AI. Okay, and so were you ever an architect? Okay, you're an architect in Azure. Okay, in AI. Were you ever an architect with on-prem solutions as well, or did you really go straight onto the cloud?
I went straight to the cloud.
Okay, so in terms of so when somebody's got like an accounting application that they want to push into Azure, you're the person who starts the initial questions about volume, data. What are the sort of like the what are the mistakes or misunderstandings that people generally have?
That it's going to be easy and painless.
I see. All
uh,
right.
Whenever there is a cloud migration project, the misconception is that it's going to be easy and quick and painless. But the older the environment, even if it's small, but the older the environment, the more dependencies there are, and the deeper you go, the more you discover. And it's extremely difficult to assess how much time it is going to take at the very beginning of the project. So
Mm,
again, I often say that in technology, in IT, technology is not a problem. Humans are, or communication is a problem. So often when you talk to project managers, they say, "Oh, what do you mean you can't tell?" Well, in IT, you really can't tell from the very beginning because it's like Pandora box. You open up and there's like Matryoshka, another box and another box and another box, and it can take a while.
so how do they respond to that? Because like, the client wants they've got a budget, they want
Mm,
predictability, they want confidence, and they want a time frame. They don't want a science
mm.
project. So how do you manage their expectations on that?
I have similar discussions when it comes to cost savings. Someone can come over and say, "Hey, we want cost saving, cut the cost by 20%." And I say, "Well, dear customer, I can cut costs by 100%. I can just click delete on your tenant and all your costs will be gone." But I guess this is not what you want. So somehow we need to manage the value that you want to get from your environment and not cut costs, but optimize costs. And the same happens with the migrations. You don't want just go into the cloud. You want to optimize your workloads. There is a reason why you chose to go to the cloud in the first place. So let's focus on that and let's make sure that those goals are met no matter how much time it takes. You want to get it well, not quickly and dirty.
True. Okay. So let's just talk about quantum computing, right? Bit of a hot topic right now. I'm at some sort of like fancy cocktail party in Brussels, and you talk about, "Oh, I do quantum computing," and I say, "What is
Mm.
that?" In a nutshell, just describe that to me while I'm eating my peanuts.
Yeah, so a quick and dirty version would be a faster computer, but it's not enough. That is a wrong answer because quantum computer is so much more than just a faster computer. You can't run a latest version of Far Cry on a quantum computer, but quantum computer, accelerated computing can help solve us problems that we are struggling right now that the current computers can't help us solve. Let me take as an example, it can help us come up with new medicines. There are certain problems that cannot be solved in many years with the computing power that we currently have. If we use the power of quantum computers, a quantum computer that is powerful enough, then we just solve the problem and we can come up with a solution that can save lives or optimize an energy distribution and can optimize costs or detect fraud and so on.
Okay, so like up to about 3 years ago, if you mentioned AI, it was always about like, yeah, that's sort of like happening in academia and it's over there, and it's sort of like there wasn't really any real life business examples which were seriously adopted. So is quantum computers, is it a reality now, or is it something which is like, is something I can touch it, or is it something which is coming down the pipe?
So there are already quantum computers deployed in data centers. In Germany, there is a physical quantum computer. If you want to start playing around with a quantum computer, you can do it via cloud computing. So if anyone's interested, the very first step I always advise is go to your cloud provider, be it Azure, be it Google, be it any other cloud provider. I can use the example of Azure because that's my specialty. You can deploy quantum workspace. You get $500 to play around with a quantum computer. You connect to it and you can start writing your scripts. Quantum is not only computing. You also have quantum sensing and quantum networks. Quantum networking. KQD, quantum key distribution, it is a form of sending information via quantum systems. These systems are distributed all over Europe. There was a pact signed all over, an agreement signed all over European countries to develop this sort of network. And it is happening. We already have this sort of network, even in Belgium, between two data centers.
Right. So, all right, so you've got boatloads of computer processing. Okay. Can you give me some real life examples of where quantum computing is making a difference in our society, in our culture right now?
I would start with the security. So, in my opinion, the foot in the door when it comes to quantum will be in security because, like I said, accelerated computing can help us solve unsolvable riddles, puzzles right now. And not all puzzles should be solved because some puzzles are protecting us. For example, encryption. Encryption is nothing else but just a big puzzle that makes it impossible for someone else to read our data. But if we have a computer for which it is possible to solve this unsolvable puzzle, well, our data is no longer protected and everyone can get access to our bank account, or everyone can read our data stored on the governmental servers, which I hope the data is encrypted. So the very first step would be to protect our data from a potential quantum attack. And that's what we're striving to do with the Quantum Circle, is to make people aware and help them introduce the post-quantum encryption or post-quantum cryptography protocols. And there are already such protocols available. Those are standards already introduced by NIST.
Okay, so when I think of the word quantum, I think of two things. I think of a quantum leap, which is a leap forward, and then you have like quantum, which is a tiny, like a quantum atom. Isn't this all a bit confusing?
Yeah, not the first, not the last thing. Indeed, the quantum leap, it's you think about something huge, right? A leap forward, while quantum physics is a physics around the very elementary particles, the atom, the photon, because a quantum computer, in comparison to a classical computer that operates on bits, 1 and 0, the quantum computer operates on qubits, which a qubit, it can be a photon, it can be an electron.
Right. Okay. And so the big players in this game traditionally was like, I think of IBM, Google, Microsoft. Who are the other guy? Who are the other big players in this? Where's AWS is another one, I'm assuming.
They are still there, of course, Microsoft, of course, IBM, but there are quite some other companies developing quantum computers as well, QEra, Quantinum. But besides the companies who are building quantum computers, there are companies that are building parts of those quantum computers that are quite interesting to look into if you want to perhaps invest into something.
So, okay, so when I think of chips, I think of Intel and AMD. Are these guys the bigger players in here, or are they jumped into this in a big way, or is it other players?
I would look into Qera and Quantinum. Those are the names that pop up into my mind. I would have to do some more research to understand better who exactly is building quantum chips at the moment. For sure, Microsoft, for sure, IBM.
Okay, now it's interesting. Like Microsoft, you don't really associate as a chip manufacturer. Okay, but you're sort of like saying that they are. They're investing into this as well.
Yeah, they are. They came up with this Majorana particle.
That's right.
And that they say they created another state of matter thanks to that particle. So yes, indeed, they are developing those sort of chips that can be used for quantum computers.
So, okay, so the processing speed is different. Okay, now, do you need to change your developing patterns based on this hardware?
Yeah, good question. So it is important to understand quantum, or the very basic principles of how quantum works, because to be able to work with quantum systems, you need to build a circuit built from gates, and gates enforce the quantum states on your particles. And a quantum state can be, for example, a superposition. So then again, you need to be aware, you need to understand what is a superposition and what it does to your qubit. So, of course, there are certain information, there are certain new data that you need to understand to be able to work with quantum computers. But at the same time, what you know as a developer will surely help you to work with quantum computer as well.
Right, because this is all pretty new stuff, isn't it? Basically, it's like, it really is like leading edge or bleeding edge as well. So who are the typical clients you typically work with?
So we, as Quantum Circle, we are an NGO, and we want to gather all stakeholders together. So we want to be a community where everyone gets together, and let's say a company is working on a project and they're struggling, or another company is working on a project but they are struggling with a policy, or government wants to build a policy, and we want to gather all the voices from the market. And I believe that a community like this can really accelerate the adoption and ultimately contribute to the growth of the market share.
Because I'm assuming, okay, what we're already talking about, how to make things bigger, better, faster, and make it more cost effective. So I'm assuming finance is going to be all over this. The defense industry is going to be all over this. They're normally anything which is a new technology. Generally, it's finance and the defense industry have traditionally, if you look at the history of technology over the last 500 years, over the last, I say, mankind, those are the two industries which generally lead a technology revolution. So, given that statement, are you in? Are those the people in conversations with you?
Mainly pharma, banking, companies from those area, tech as well. They are looking into enhancing their capabilities and making sure that their data is protected. Even if you look at the US market, the main banks who are involved within quantum, they are from across the ocean from me. When it comes to the governments, I don't think they would be happy to share their projects. And I know that there are lots of companies who are already working with quantum, but they are not happy to talk with us or to share the case studies just because they see it as a competitive edge, which we're trying to change their mind about that, because we say like, hey, you take a certain quantum algorithm and you don't have to share the details, but you just work further on the algorithm that can be reused across the industry and you grow as an industry. But it's a difficult conversation because it is a new technology.
Sure, and also there's national security as well, on that, particularly in the current economic climate. So, as a developer, where would you, if the developers who are listening into this, where would they start? with quantum? What, like in terms of places to look, things to do, things to learn. Where's like if I was going to learn, if I was going to learn French, okay, you probably watch a couple of French movies, perhaps visit Paris, read a newspaper. To be a developer in quantum, where would I go?
Yeah, I that wouldn't be my advice to go to Paris if you want to learn French for sure. But
Because everyone speaks English. Yeah. Okay. So Nice then, or yes.
But when it comes to quantum, a really nice idea that you can get about the technology, you can get that on a YouTube channel. It's called Veritasium. That if you want to go a bit deeper into developing the actual solutions, a colleague of mine, Johnny Hoibergs, he wrote a book introducing Microsoft Quantum Computing for developers. You can follow the community, Quantum Circle community on LinkedIn, IBM, and Google as well. They have and Microsoft, of course, they have quite some materials, courses on quantum as well, together with exercises.
Okay, question just came in, and it was, if they want to get into quantum computing, is it worth buying the hardware or basically renting the hardware in somebody's cloud, like Azure?
If you have spare 5 to 20 million euro, then I think you can buy a quantum computer. But it depends on the spare change that you have in your piggy saving account.
All right. So with Moore's law, was every 2 years the price halves. Okay, so we're looking at probably the next 20 years, it might be a bit more available in Best Buy or Amazon. Is that what you were basically hearing here?
Perhaps the hardware, but then you need to pay for the energy. So I would definitely advise to go via cloud. It's more cost effective, especially for the beginning, because I don't think you need a quantum computer as a user on regular basis. It might change, who knows, but at least at the beginning to just play with accessing quantum computer via cloud is more than enough.
So obviously, if you're on a data center, you're really sharing the processing speed, aren't you? You're sharing, it's a shared tenant and everything else. Okay, so in terms of, so in like transportation, you do need a lot of speed, you need a lot of processing power. Okay, that's a good example of that. So is this, I'm assuming a lot of these, we say, massive SaaS applications like Facebook, Google Maps, GPSing, Internet of Things, driverless cars. These are the perfect case studies for quantum.
You mean for quantum?
Yes.
So quantum is not 1 or 0, right? Quantum operates on different principles than a classical computer. So like I said, you can't run a Far Cry. You can't game on a quantum computer. Quantum computer can help you solve a problem, let's say a machine learning problem, can help you optimize, can help you detect a fraud, because if you have a lot of data and you try to find a pattern in the data, quantum computer can provide this computational power and can help you find an anomaly in your data, for example. But to play a game or to run a car, currently, this is not, so to say, in scope.
Right, okay. Right, someone just put a question in, or it's a quote by Zuckerberg. And Zuckerberg is saying he understands that the technology is still quite a way off from being a useful paradigm. Is that a fair statement, or it's closer than you think, or it's already been?
It depends what you compare it to, because a lot of CEOs I talk to, they say, well, we're not investing in quantum because we have AI, so we're focused on the AI, which is a fair point, right? But being CEO, managing a company, you can't only focus on short term, right? You do get a quicker return on the investment from AI. That's absolutely fair and square. But you need to look in long term. And quantum computer can perfectly complement AI. And you mentioned Moore's law. The whole reason why we're talking about quantum computing right now, it's not because we needed something interesting to talk about and, well, there was AI, we need something else just to complement it. So the Moore's law that states that every 2 years the processors are getting smaller, and so we can get quicker computing power, we can process more data. We reached a plateau. So we physically can't get more from our current computers. And look where we are. with our AI, we desperately need more computing power. So we either find a way towards further miniaturization, or we find a different computing type, which can be quantum computing. And looking at the investment and the amount of money pumped into quantum computing, the promise is quite huge that can be the next best thing.
Yes, well, we've always heard the promise. We've always heard like the promise of the next best thing is always a lot of promise. Whether it comes to fruition, we've always seen this a bit. Like, do you remember the Segway?
Yeah, sure.
Yeah, that was supposed to revolutionize cities. Okay, in America, you have the GPS. I believe Europe had an equivalent of the GPS called Galileo. They had an equivalent. It was called Galileo or something, and it was or that. And of course, then the key thing is that you need adoption.
Mm-hmm.
Okay, so
Absolutely.
technology on its own is not enough. So standardize on the standards, adoption, an ecosystem. There's a few other things and timing as well on that. So okay, so here you're saying quantum computing, it's around. There's use cases. When do you think it's going to be? Like 2 years ago, AI became the hot topic. Okay, when is quantum going to be the talk of the town? Where it's going to be prime time?
Tomorrow or in 10 years. And there is a good reason why I'm saying that. So the way tech works, and you know it, it's nothing special that I'm going to say. There will be a breakthrough, and suddenly we reach an error-prone quantum computer. We have noiseless or we reduce the noise of our qubits. And I can't predict that. No one can predict it. We can say that, well, looking at the funding and looking at the universities researching the quantum computer, looking at the companies working with the quantum computer, looking at the Googles and Microsofts and IBMs of this world and teams that they dedicated to work on quantum computers, we can say that there is a high chance that it will be the next best thing. But a lot of people are asking me for the actual date. It is extremely difficult because it depends on this particular breakthrough that will change everything.
Okay, so this is a bit like in the late 90s, that Google moment when we first started using Google, and it was like, aha, this is amazing. The ChatGPT, when that came out, that was that moment where AI, everybody was just jumping into that, and it was something like, well, this could do. So and you're really sort of like saying that Google moment, that ChatGPT thing, it's coming, but we really just don't know when.
It's similar like with ChatGPT. I remember when I first of all, there was no ChatGPT. Some people work with AI, but come on. Then the ChatGPT happened, and I remember my first tests were very disappointing. I even asked it a couple of Azure-related questions, and it got it wrong. And now look where we are. I can almost fully rely on its answers in a perfect tone and a perfect formatting. So it is a process, but there's always this one breakthrough when everyone says, this is it.
Yeah, and quite often that happens. Like if you look at Google, there was a dozen, if not more, of search engines that everybody was using. Yahoo, Ask Jeeves, Alta Vista. They were all those are all around, and they were all humming away, working fine. And then Google just cracked it. Okay,
Yeah.
And with ChatGPT, that was the first one. There were other ones which I hadn't heard of, but ChatGPT was that breakthrough moment and that breakthrough platform that basically everybody was just talking about.
Yeah, and you can see in news that we are getting there. I started getting interested in quantum, I'd say 3 years ago, and there are estimations that it will take maybe 30 years, maybe 20 years, and the time is shortening. Now we are saying maybe 10 years, maybe 5 years, we don't know, but we're closer and closer. The main barrier to getting this quantum breakthrough is reducing the noise of qubits and making the qubits less error prone. So in human terms, so to say, the real power of the quantum computer, we get the real power of the out of the quantum computer when we join a lot of qubits together. Similarly to a classical computer, the more bits you join together, the more powerful computer you get. But with a quantum computer, we have an issue because the more qubits you join, the qubits get noisy. So the more qubits you get, the less relevant results you get. So why do you need a computer that gives you irrelevant results? Not fun. So there's a lot of research done in this direction so that you can get a really powerful quantum computer operating on a lot of qubits at the same time with a high relevance ratio.
That is true on that. Okay, so in terms of your role in your organization, how big is your organization that you work with? It's an NGO, it's just a not-for-profit. How big is that? How big is it?
We operate in Belgium, and we are focused on our market here. We have dozens of members, if not hundreds, if you count the internal members and then the associated companies.
I'm assuming this, because it's in Brussels, this is some EU funded. I'm assuming you're trying to get leverage off the EU and all the member states in there.
Yes, and apart from that, AA lead for Azelis for another company.
All right. Okay. Very, very cool on that. We're getting a few questions coming in. So one question that came in, he said that this was a long question. Okay. Basically, if you look at the gold rush in 1889, okay, there was in California, there was a gold rush. Okay. That was a big gold. But the people who made the money on this were not necessarily the miners. They were the people supporting that industry, like the people making the shovels or Levi jeans.
That's a very perceptive question.
Okay, and that's why I said that who are going to be the jeans and the shovel maker winners of this? I'm assuming it's the people who are why Google is investing in nuclear power stations or anyone producing energy. Are these people going to be the winners there?
Mm-hmm.
I think I've stated that question correctly. If I'm not, please add to that. I'm talking to the person that.
Even a couple of days ago, I was talking. I was looking where to invest. So naturally, the first thought, okay, well, quantum, right? But then I thought, but is it a good direction? Should I invest in companies creating quantum computers, or companies creating components for quantum computers? And indeed, that's exactly the question being asked, that it is a good idea to look at the companies that produce components used to build quantum computers.
Mm-hmm. Right. So it sounds to me like you're giving investment advice here. Like, do you have any inside knowledge just for anyone here?
No, not at all. Not at all. We're just having a conversation.
Oh, okay. I see. Oh, no. All right.
I wish. If I had, I wouldn't be here. I would be on Bahamas sipping my drink.
Right. Okay. There's a few other questions which we asked you prior to this. What's the biggest and the worst technical advice you've been given? Now, you said quantum computers will replace classical computing. Quantum computers are just faster. That's the best advice. Build a quantum-inspired solution today. No fault-tolerant quantum computing for tomorrow. What do you mean by that?
Yeah, I believe that I mentioned some myths around the quantum computers. The worst, or the myth that I quoted, was some people believe that indeed the quantum computers will replace the classical computers, which is not true because, like I mentioned, quantum computers are a different type of computing, but for now, they work together with classical computer, but they will not replace a classical computing. And regarding the best advice, everyone's asking for, okay, give me a use case, right? That works right now, which it misses the point because you might not get there right now. But the point right now is not to get to a fully fledged quantum computing case that will blow your mind and transform your company and turn it into a multi-billion organization. The point is to get interested, to know how to use quantum computing so that when the moment comes, your organization is prepared. You have the inside knowledge to leverage the quantum computing and then accelerate.
Okay, that makes sense. All right. Okay, if there's any further questions coming up here, okay, I'll give you a few seconds. I'll give you 10 more seconds. Okay, I've put your LinkedIn profile and you're working on your website. So I've just put your website in there, quantumcircle.eu. Okay, is there any other blogs that you look at that you get your information or where people can find you?
No, like I said, I'm working on my personal website, but that's work in progress. So to be seen.
No, okay, no problem. Okay, Hannah, thank you for your time. And I think you're the first speaker we've had from Brussels, actually, I have to say. We've had Portugal, Italy, France, London, the usual suspects. Okay, but you're the first one from Brussels. So thank you for being a guest. And do you ever speak in New York?
I'm honored to represent. I never spoke in New York. I never been to New York either.
You've never been to New York?
No.
All right. Well, there's always a day. All right. Well, thank you for your time and have a good night.
Good night to you. Bye.